Welcome back to the channel, Tech Enthusiasts. Today we're diving into another fascinating topic in artificial intelligence: embeddings. These powerful tools are the backbone of many AI systems, enabling machines to understand and process complex data like text, images, and even user behavior. We'll explore what embeddings are, how they work, and their transformative applications across industries. So let's get started. Embeddings are a way to represent complex data, such as words, images, or even entire documents, as numerical vectors in a high-dimensional space. Think of them as a translation layer that converts raw data into a format that machines can understand and process. For example, in natural language processing (NLP), words like king, queen, or castle are transformed into vectors of numbers. These vectors capture not just the meaning of the words, but also their relationships to one another. To understand this better, let's use an analogy. Imagine you're organizing a library. Instead of arranging books randomly, you group them by genre, author, and theme. Embeddings do something similar for data. They map information into a structured space where similar items are closer together and dissimilar ones are farther apart. For instance, in word embeddings, the vectors for king and queen will be close to each other because they're related, while apple and orange might be closer because they're both fruits. Let's break down how embeddings work. At their core, embeddings are created using machine learning models like Word2Vec, GLOVE, or BERT in NLP, and convolutional neural networks (CNNs) for images. These models learn embeddings by analyzing massive datasets and identifying patterns. For example, Word2Vec learns word embeddings by predicting a word based on its context, like the words around it, while CNNs learn image embeddings by detecting edges, shapes, and textures. The applications of embeddings are as diverse as they are revolutionary. In natural language processing (NLP), embeddings power search engines, chatbots, and translation tools. For instance, Google uses embeddings to understand search queries and match them with relevant results. Similarly, chatbots like ChatGPT rely on embeddings to generate contextually relevant responses. In recommendation systems, platforms like Netflix and Spotify use embeddings to represent user preferences and recommend movies, shows, or songs based on similarity. In computer vision, embeddings help AI recognize objects, faces, and scenes in images. For example, facial recognition systems use embeddings to map facial features into a vector space, enabling them to identify individuals with high accuracy. In healthcare, embeddings are used to analyze medical data, such as patient records or genomic sequences, to identify patterns and predict outcomes. This can lead to faster diagnoses and more personalized treatments. As this technology evolves, its integration with other advanced AI systems will unlock even more possibilities. Researchers are working on multimodal embeddings, which can represent multiple types of data, like text and images, in the same space. For example, OpenAI's CLIP model uses embeddings to connect images with textual descriptions, enabling applications like generating images from text prompts. Another exciting development is the use of graph embeddings, which represent relationships between entities in a network. This is particularly useful in social network analysis, fraud detection, and knowledge graphs. However, embeddings also raise important ethical considerations. Bias in training data, such as racial or gender biases in text or images, can affect the fairness of AI outputs. For example, word embeddings might associate certain professions with specific genders, reinforcing stereotypes. Addressing these challenges is critical to ensuring that embeddings benefit everyone. Additionally, the abstract nature of embeddings makes them difficult to interpret, which can be a challenge in applications where transparency is essential. The future of embeddings is incredibly promising. From powering intelligent search engines and recommendation systems to advancing healthcare and computer vision, embeddings are at the heart of modern AI. As technology continues to evolve, embeddings will play an even bigger role in shaping the future of intelligent systems. That's it for today's episode. If you found this deep dive into embeddings fascinating, don't forget to like, subscribe, and hit the notification bell for more AI insights. Drop a comment below. What's your favorite application of embeddings? Until next time, stay curious and keep exploring.